Jack Graham, really a nice looking guy and a lot of fun. Had a lot of problems, came up laughing out of every one of them. Nothing bothered him too much. He and Walt really ran a good job. Walt was a great little guy. He always reminded me of a fox terrier. He did a lot of barking, but he really was one swell guy and a very good rigger. He learned his trade in the logging camp, believe it or not. Orville's son, general manager for Foss Tug Company. And Ralph Keenan had to be an excellent engineer, there's no question about it. Ran a very good job, had a good corps of engineers that had workshops every week to meet problems head on before they became serious. I hate to see him drive another nail in his coffin there, though. Now, Ted Cuse, I really didn't know. He worked in the office, I think, most of the time. Well, this is a fine-looking man, but they don't give him much chance to see that. Now, you're really, I think, on the Tacoma side looking west. And we know where you're looking here. You're looking directly east. Mount Rainier is beautiful. This is a good view of Schofield's operation at the foot of 15th Street. After I finished the dock, my crew and I unloaded supplies for Pacific Bridge, which kept us very busy. When the diving started, I was given the 4:30 to 12 shift, not much supervision, which I took as a compliment. I might say my first job on the diving scow was to put diver Johnny Bacon down on a bosun's chair just 10 feet above the bottom. The water was 120 feet deep. Ralph Keenan, general manager, Jack Graham, Walt Cathy, myself, Roy, and the diver's tender were on the scow while the tugboat towed it slowly over the area for the West Pier. Johnny told Roy the water was very clear and the site needed no preparation whatever. This was good news for Pacific Bridge Company. The east side was so steep it needed considerable dredging before a site level enough for a pier was achieved. 2 anchors did break. Bill Lottie and Johnny Bacon repaired one with cable on my shift. The east side was required much dredging before a site level enough for the pier was achieved. This is Hemlock Gibson here. He worked for me on several different jobs. He came honestly by that name Hemlock, but I won't try to tell you about it here. They're taking everything loose that holds that anchor from sliding off the scow. It's well blocked, I'll tell you that. I'll tell you, he didn't always win it though. Well, that's Johnny Wyckoff there, state engineer I've known for a long time. He evidently won that bet. Everyone was required to wear flotation vests there. Believe me, if you fell in there with a tide running, you very well could lose your life. Hey, it looked like Jack picked up some more change there for some reason or other. Yeah, that's what he's doing. Watch this cable that these men have in their hands there. Oh, excuse me. This cable here, we handled thousands of feet of that, of all different sizes, before that job really got a good start. I started to tell you about pulling the plug on the scow so that the anchor would tip off, but that'll come up a little bit later. Rough water is right. 3 experienced divers there, and one of them told me if all 3 of them lived through this job, he said he felt they'd be very lucky. The Louise tended us any time the diving scow was in operation. Well, they use short wave there to... Now, 2 plugs are being pulled. Watch these men with this little... See that line right there they have in their hands? The ends are fastened to plugs on this end. Look at the tremendous flop that scow takes. Now, believe it or not, we're going to give you a rerun on this. I'll put it back on and you can watch that once more. I think this is a pretty neat trick, don't you? Was lost coming around Point Defiance and the whole process. I think that's before they found that when those scows took that flop, they had to put them back and go over the caulking on every trip. Every time they're dumped, they had to do that. Now, this is Johnny Bacon getting ready to go down and inspect the anchor to see it's not broken or anything. A very good diver, little guy, and he had a Roy. His tender wasn't any bigger than Johnny was, but I'll tell you, there were 2 very fine men, knew what they were doing, and Roy had Johnny's safety on his mind all the time he was down. A nice gang to work with, too. Well, we're up in Lake Washington now. That's the caisson just starting out on his trip. That is the Wanderer, the oldest steam tug working on the Sound, owned by the Foss Company. The bottom part of that caisson is steel. It was made by the Pacific Car and Foundry in Renton. Now that's a Mont Lake Bridge there going through there in Seattle. Fortunately, there was no distortion this time. It comes on there when that goes under the bridge. Now here in the locks, you'll notice that man is using what we call a softener. Also notice that caisson is built on a scow, and notice these pad eyes here. They will be used to pick that up and take the scow out from under it before it goes on down to the bridge. I imagine that's down at Puget Sound Bridge and Dredging where the derricks are put on. Well, that was the caisson for the West Pier, which came down with the derricks all set up ready to go to work. Jack picked up more money there, just sure as the dickens. Now it says here that Matilda Foss puts out into the fog. And she supposedly towed that clear down, but I don't know what happened. It didn't work that way. I was on that caisson when it came down to the site for the bridge. And they had us, it was so late in the evening when it came that they had put several of us riggers aboard, and it was towed on down to 6th Avenue and tied up for the night there. It was the Wanderer that brought her down. Then we had to have it towed back to the site the next morning. The Matilda Foss was not on it when it came down there. Now, at the site where the pier was to be, we had 2 rigging scows anchored solidly there, and they were fastened together right directly over where the pier would go. Well, when the caisson came in, the rigging scows were pulled away, and the caisson floated in there, and the rigging scow, you can see one of them right there now, and there's soon another one's on the other side the way they were before. Now, they were anchored solidly and temporarily could hold that caisson in place there, but of course they got the heavy lines on as soon as possible. For, I have forgotten, it was well over 26 or more anchors. You can see here they're putting the heavy lines on that'll hold the caisson in place. The line that goes to the anchors from that block and tackle there is inch and 9/16 with a breaking strain of 175 tons. And it takes a man to patrol those lines, or someone on that 24 hours a day, because the tide flows one way or the other, rising and falling. They have to be slacked and taken up. So it's quite a busy time out there for someone watching those lines. One man had to patrol that all the time, night and day. Now you're seeing something here that I didn't have an explanation for at first. But there is the caisson with no guy derricks on it. Now this had to be the caisson for the East Pier, which they are putting the derricks on there now. They evidently figured they had plenty of time to do it, and they saved money while that dredging is being done to get the spot ready for that. And they evidently put their own derrick on. You can see there's a lot of rigging on those scows there yet. The west one, the only time there was no derrick showing on that is when the derricks were supposed, this is dredging for the east side, which is highly necessary. But when they were the only time the derricks on the west side were down was when they were designed for one to pick the other one to the next level. And the first time they tried it collapsed, and they had to do a lot of rebuilding on booms and so forth. And from then on they used electric winches, one on each corner, and they were a perfect success from then on. This going through here now is tool room and lunch room that goes over to the east caisson. You'll see it there later. Well, there's a rigging scow here in front of you with a lot of equipment on it, and everybody's working anyhow. This was a night and day operation. Put up more steel, put up forms, pour concrete, put up more steel, raise derricks, pour forms, and so forth. That shows you how fast that water was there. Justine Foss was an outrigger. I never could figure out what it was for. Now watch this runabout come in there and pick a man off the stern of the Justine. Watch this now. Probably the Justine's going back to town and that's going over the west side. You can see how fast that tide runs there too. So you can see why heavy anchors were necessary. Now that's heavy cable anchorage being excavated there. And you can see the mixer plant just over the side, and out in the middle is the West Pier. Or not in the middle, but in the distance there. Sure, rough looking road ahead there, isn't it? Now you see the cable anchor already cast, and there are the eye bars. Heavy pin goes through, and on each side of the eye bar are they call them shoes. They look just like a shiv out of a block and tackle, and the cables are literally formed around there. The individual strands are formed around those shoes, so they ride on from the start. Very interesting. And you have the mixer plant there, and there's the West Pier. Just barely see the mountain in the background. Pot scows coming in for concrete. The last job I did for Hart Construction Company was to drive piles through the dock, through that mixer dock for the mixer plant itself to sit on. I wished I could name that man. I know his face very well, but I cannot come up with his name. Well, those are empty anyway. See a place to set an empty bucket in there. I wish they'd show us doing it. He's got to shoot that hole just right. Well, that's a full bucket. They're going to show us how they pour concrete. What you're looking at there is the walls to these cells, which are kept vacant. These cells are open from the very top to the very bottom because they have to break when they get to the down and start ready to start digging. They break the watertight bottom out of those cells and use the clamshell, and from then on they sink it. Dig it down and put more forms up, pour more concrete, and dig some more. You can see those heavy fenders that we built prior to the caisson coming in. L-shaped fenders that fit right around the caisson. Walkway and more anything too, they were built very solid, bolted together well. If you were standing on top of that pier or caisson, it's caisson, well, I don't know, I guess it's a pier now down there because it's quit floating. When they are digging, you can feel that settle, and it's just like you're standing on a little earthquake. You can see they're putting the steel up here, and when they get that all built up again, they'll pick the derricks up and set them on top of that, and then go again. I imagine that may be one of the electric winches they use to pick the derricks up with there. I'm not sure. But when they do pick them up, there's an electric winch on each corner. Now these scows here are loaded with what looks like it might be boxes. What they are, literally, they were panels made at Henry Mill by Don and John Buchanan, and they were bolted together there, and so that they are preformed. All they had to do is to pick those forms up and set them in the steel work and bolt it, and they're ready to pour again when they get their reinforcement rod in and all that. In bridging the Narrows, you will find much more detail in pouring the seal on the bottom with a tremie. Actually, it's a long tube with a funnel on top, and burlap bags were stuffed in the funnel, and when the concrete was poured, that acted as a piston and pushed all the water out down below, and as long as it was kept in the fresh concrete at the bottom, no water could get in. Of course, if you moved to another place, you had to do it all over again. Well, we're on shipboard now, after tar steel. Being put on Foss's scows, and then they'll be transported out to the job site. They handle that heavy stuff fairly carefully now, I'll tell you that, especially with a couple of men down below and setting that down in those scows. Have to have a balance the load more or less too as they put it on. Those spinning loads like that used to bother me a lot. About 1950, they brought in non-rotating line. That is, I got it the first time along in 1950. You could pick up a heavy load without having all that spin to it. I want you to notice this operator way up high on the mast. He's where he can see everything well, but he also has to take very exact signals. Some places you can't see quite that good. Right there he is, looking at you from on top, high up on the mast. Looks like that corner must have got banged up a little bit to go down in a tight spot there. Notice what a tight fit that is. Don't look like that operator has very much protection if the weather got bad up there, does it? Well, that's a good view of where the derrick sits. That's the elevator that brings the men down to lunch. Well, they got a lunch break. Everyone's headed for that lunchroom and tool house that went by there some time back. Well, you're seeing part of the cable saddle there. You see it sitting on top there. Very soon. There it is there. That's just part of it. There's probably another piece just like it and then a centerpiece. Right there you have the mixer dock with a tramway that went up to pour that anchor that was poured back on the west side. A heater is a very important man on a riveting crew. You notice how he's throwing that rivet up. Now you watch this one, just came put out in that pneumatic tube. There it goes in the hole. A dolly bar is put against this side with a head on it. Riveting gun on the other side makes a head. And as it cools, it draws that cold iron together tighter than ever. I don't think there's any construction better than a well-riveted seam. They're totally wrong about that 104 feet. It was 90 feet according to the engineer's data that I got from Olympia. Here comes the wire for the cables now. I'm glad to see them get on the job. It'd be pretty hard to build a bridge without that. And you'll find this is quite a complicated process too, really. Two men that designed this machinery you're going to see here were sent out by the Roebling Company. They call them the human spiders, H.C. Amos and F.M. Marin. They've been spinning cable together for 15 years. Nearly every suspension bridge erected in the country at that time has had their services. or that of the machinery designed for them. I'm sorry I can't put a picture on here of them, but I don't have it. There's more machinery to this than a person would think. I never dreamed there was that much, really. Just look at it. The so-called cable spinning process is really something to watch. You see most of it, most all the operations fairly well here too. Incidentally, there's number 6 wire that is used. Notice how this end is handled here now. There is a ferrule that holds the two ends together, splices it together, that number 6 wire, and it's put on with such pressure that that joint will withstand the break and strain of the wire. In Galloping Gertie, there was 19 strands to each cable of 300 and I believe it was 30 strands, 30 wires to the strand. And the present bridge had 400 and either 56 or 58 wires to the strand, same number of 19 strands to each cable. Difference in size there, though, will make quite a difference. And what they're putting on there now, I like to think is lubrication, because those wires travel through a lot of shivs before they reach their final destination. And I think it undoubtedly lubricant is required. Now there'll be 2 wires put on each side of those 2 shivs. They've got grooves on each side for 2 wires on each side there. That's 4 wires that are going out there now. Double that and you have 8 then. You have something very interesting right here to look at. Those weights going up and down there cannot hit the bottom, and they must not hit the top. That man has to keep them in suspension at all times, and that puts the even tension on that wire. Otherwise, the chances are he'd get canned if he hit the top or bottom with it. You can be sure of that. Now watch this man put that wire around that shoe, so-called shoe there. He puts it exactly where he wants it. And with those ferrules put in there, as you will see, there are no ends. There he's putting extra pressure on the ferrule, right there with that vise. See those vices in a row there? The ends must come up similar places. And you will see a little bit later, look at put those wires on right there. That's a good view of that. A little bit later you will see a little more of this work on the ferrules, I believe. Well, that's the cable wrapper up there. This is the way to get over the clamp that holds the suspender cables on the main cable that you just saw there. There you see the shoes. That's the main anchorage right there you're looking at, where this man's standing with his hand on one of the cables there. One of the strands, I should say. Now here's some work they're doing right on those, oh darn. Well, watch closely. I think we'll see a little bit more. They're working on those wire ends right now. Right here at the bottom of this picture, you'll see just to get a short glimpse of one going on. Right there it is. See, there's your ferrule right there, and the other wire is about to be inserted in it. You must admit there's a kind of a complex operation here. There we are, still going around the shoe with more wires. And right there you have a sample of where that cable goes through one of the saddle. And there is where the zinc fillers are used to, zinc is soft and they're fairly short, and they're wired, their wire runs down the center of them and is laid in to maintain the round texture, the round diameter of the cable. Otherwise it would be pretty rough. They fill the voids between strands, in other words. That is the framework of the wrapping device there, and there's one of the cable saddles right on. That's the peak right there. Peak of the tower. And you're looking at the other side of it now. There's a peculiar operation here, but they must have some object in doing it that way. Here we are at the anchorage and where the strands go into the main cable. There you have a good picture of it right there. And there's your anchorage. You're looking right back at it. One of the suspender cable clamps going on the main cable. Those fillers, there's the bosses. I can't tell you the names. I'm not sure. I better not say any names at all because I'm not at all sure. I believe that one you just looked at was Andy Zori, but I'm not positive about that either. Well, it looks like a... Well, here you got a couple of riggers getting a little ride. Pulling slack, it looks like to me. Why, I don't know. Well, you see some riggers working on the deck structure now. That man there is trying to capture one or two of those wires out there. I don't know why, but anyway, that's what he's doing. There, how'd you like that? I wouldn't know what he's doing any more than getting a ride. That is likely the first piece of deck section put up that you just looked at. When they hang deck in the middle, they must hang some on each side to help keep the strain equal everywhere. Balanced off, you might say. Now you see them fasten the jewels on the end of those suspender cables in just a moment, which support the deck. Bridge, I might say. I will say that the jewels are zinc, which melts at around a little less than 800 degrees. But I was told by Jack Durkee, one of the foremost bridge engineers in the world, that there is no danger of flaming gas melting them with all the heat sinks there is around them. He says if you and I had them in a laboratory and tried to melt them with flaming gas, we could not do it. I think that scow has a work platform on it. Yeah, just picked off the scow now. Now watch this closely. I think some men rode up on it. Yes, I'm sure they are. You can see them now. Well, that's a nice look up the bay there now, anyway. See how far along they are. Everything getting a coat of paint. Well, here's that expert heater again. Look at that. Accurate? You bet. Must be the right rivets, right length, the right heat. Make no mistake, he's a very important man in that crew. Now watch this fellow here. And then imagine today building that bridge with no... Well, they wouldn't allow them to do it, anything like that at all. They have to have be tied off every place they work, and I don't know how they could build a bridge and do that. That remains to be seen. There isn't one of these fellows that ever fell off from this Galloping Gertie. This may be the last section in the bridge that you're looking at right now. Well, it looks like we're ready for the deck. That was the old way of doing it. A lot of work, too. Well, this is the place the dignitaries take over. I wish I could name some of them for you, but I can't do it. Watch this gentleman with the white suit. He's something to watch. I don't know whether he goes up there and prays for that car or what. He's not trying to crank it, I don't think. I don't quite understand what he's doing. He must be blessing it. I don't know. Fact is, that is a Lincoln, believe it or not. It looks like an old Model A, but it's one of those three-seated Lincoln limousines. There we go, that white suit. Well, there's 65. When you see 55 pop up there, that's the end of this part of the show. Beautiful mountain picture. When the sun is out, this picture is very good, but when a cloud comes over, it sure cuts a lot of the quality off, as far as I'm concerned. And I will say that this bridge was constructed against the wishes of the state highway engineers. They wanted open truss work. They did not ask for that type of a bridge at all. But the government money required that they have someone else draw up the plans that came up with this 8-foot girder, which was a lot cheaper. And we know what happens. It took a terrific beating before it let go, though, I will say that for it. I measured the angle one time on one of these pictures, and that bridge is actually reaches about a 45-degree angle there before it starts back down the other side. It's amazing to me that the light standards still stood up and under all this. Well, we got a cloud over it now. I guess somebody told those people they should move out of there. Our construction company's pile driver was right over there and underneath that approach on the other side of that tower there. You can just barely make it out. Bud Brown was one of them, and the crew there told me that they wondered for a while if they were going to get out of there alive or not, because there was some concrete came down there. I think it's the state engineer there with Professor Ferguson. I was told that some of the steel that was salvaged out of this bridge went up on the Alcan Highway, and that bridge stood a little over a year before it went down also. So it sounded like steel was jinxed, don't it?